Hello, I welcome you all. The problem reads a 1 pound ball A is traveling horizontally at 20 feet per second when it strikes a 10 pounds block B that is at rest. If the coefficient of restitution between A and B is zero point 0.6 and the coefficient of kinetic friction between the plane and the block is 0.4, determine the time the time for the block B to stop sliding after the collision. So this problem is coming from the Engineering Mechanics and Dynamics of 14th edition by R.C. Hibbeler. We're dealing with impact. We have a ball that is moving at an initial velocity, and then later on it collides with a stationary block, and then of course the block then begins to move, but there's friction on the surface, begins to slide, and the question is how much time, okay, will it take for the block to stop sliding after the collision? So let's try and demonstrate. Draw this. We draw this to see what is happening. So we do have a ball like so. We have a ball like this, and we have a block. Okay, so this is A and this is B, and our M here is just 1 divided by 32.2. 32.2 is the acceleration due to gravity, this is MA, and then we have MB, which is just equal to 10 divided by 32.2. Of course, we have velocity in this direction like this, and our V here, okay, is just equal to 20 feet per second. 20 feet per second. All right, and then we do have mu k here, which is the kinetic friction, which is just 0.4. Right. So what else do we expect here? Of course, we have the weight, we have the normal force, and then once this is hit, it tends to move this direction. Therefore, you expect friction to be in that direction like that. So this is Fk, which is just equal to mu k NB, which is equal to 0.4 NB. This is NB. This is WB, which is just equal to 10. This is equal to 10. I think we have all this information. So what we need to do now is to apply all the principles, okay? All the principles that we have learned in the previous sections, okay, to this particular point where we're dealing with impact. So then using here, okay, momentum is conserved using the conservation using the conservation of momentum. We are going to say we have MA VA1 plus MB VB1, and this is equal to MA VA2 plus MB VB2. But we know that this is 0 because VB1 is equal to 0, or its initial velocity, right? And we also know that our VA1 in this particular case is 20, and therefore, and then we also know that our okay, the other information we already have it. So what MA is just 1 divided by 32.2 by 20, okay, plus 0. This is equal to 1 divided by 32.2 VA2 plus 10 32.2 VB2. Of course, this and this and this goes, and therefore what we remain with what we remain with is 20. Is 20 is equal to VA2 plus, right, so here VA2 plus 10 VB2. So this is equation 1. So now let's develop another equation. We've been told here E is equal to VB2 minus VA2 divided by VA1 minus VB1. Well, we are assuming this is greater than that. Right, and then our E here is 0.6. Our VA1 is 20. And our VB1 is 0. So we have 0.6 is equal to VB2 minus VA2 divided by 20. Right, so here this just becomes 12, right? Is equal to VB2 minus VA2. So VB2 is just equal to 12 plus VA2. This is equation 2. Okay. So solving the 2, we have 20 VA2, 10, 12 plus VA2. So VA2 therefore is just going to be equal to as 20 minus 10 by 12 divided by 11. So this is a minus 9.0909. Right, so VA2 is just equal to 9.0909, and then it's going in this direction like that, because this is our reference. Into VB2, so we have minus 9.0909. We're using this equation here, plus 12. This is 2.9091. And then our VB2 here is just equal to 2.9091 feet per second, and it's going in this direction. Alright, so we have this part here to find. So let's say time t for the block B to stop sliding. So use the principle of impulse and momentum. So we have F times t, which is equal to final velocity of B, 2, then minus initial velocity of B. And our F here is just minus Fk, Fkt, which is just equal to 0.4 by 10 by t. And VB2, since it's coming to a stop, this is going to be equal to 0, and VB1 here is just equal to 2.9091. So we have minus 0.4 by 10 times t is equal to 0 minus 10 divided by 32.2, right? Times 2.9091. Therefore, t is just equal to 2.9091 divided by 32.2, okay, divided by 0.4, and this just gives us a 0.2259. Okay, 2259. I think this is about it. We have found the time. This is the time it takes for the block to stop sliding. So I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye, and I'll see you in my next screencast.